Hello friends, today the topic for our learning session is tabulation method. We have learned different techniques for Boolean expression simplification using Boolean laws like identity law, idempotence law, associative law, distributive law, De Morgan's law, and many such other postulates. The next method is Carnot method, which is well known as K-map. 2 variable K-map, 3 variable K-map, 4 and 5 variable K-maps. Now, today we are going to learn a new method, that is Twin-McCluskey method, which is also known as tabulation method. We can easily simplify the Boolean expression up to 6 variables using K-map. But what about the Boolean expressions comprising of more than 6 variables? The simplification of such expressions becomes complicated using K-map. Thereby, at that point of time, tabulation method is handy to be used. This method is suitable for hand computation as well as the computation by machines, that is, it is easily programmable. The steps to be followed for carrying out the tabulation method. The first thing is to list all the minterms in the ascending order. The second thing is to arrange all the minterms in such a manner that each group comprises of equal number of ones. For example, 0001 and 0010, that is 1 and 2 in the decimal, comprises of one single one in a group. Similarly, if we consider the example of 0011, that is decimal 3, and 0101, that is decimal 5, comprising of two ones, are allocated in a single group. The next step is to compare these successive groups. Whenever we find a change in only one bit, we place underscore sign, or we can say the dash sign at that position. For example, on comparing 4 zeros and 0001, we will be getting the change in the LSB bit, that is, the new term would be 000 and a dash. The fourth step would to repeat this above step, that is step number 3, and to continue this type of combinations between the successive groups until and unless we are obtained with prime implicants. The next step is to formulate the prime implicant table, where we will be obtaining the essential prime implicants. Repeat this above process until and unless we are reduced with the essential prime implicant, and thereby we can obtain the Boolean equation. We don't need to worry about these steps at the moment. We will be solving all these steps by taking an example. Let's take the example. Here the given example comprises of the minterms 0, 1, 6, 7, 8, 9, 13, 14 and 15. I have written already the binary equivalent of these minterms. Now we will be grouping it in terms of number of ones in the binary representation. That is, the decimal 0 comprises of 0 ones in a group. 1 and 8 comprises of single 1. Decimal 6 and 9 comprises of two ones. Similarly, 7, 13 and 14 comprises of 3 number of ones, and 15 comprises of 4 ones. Now we would be clubbing all these minterms in a group in such a manner that each group comprises of equal number of ones. For example, index 0 comprises of 0 ones, index 1 comprises of single 1, index 2 with 2 ones, and so on. Now Our next task would be to pair the successive group and to obtain the column number 2. Now, we will be comparing the successive groups. For example, on comparison of index 0 and index 1, we can find that here there is the change in the LSB bit whenever we are comparing 0 and 1. And so, as per our rule, we will be writing over here 3 zeros and dash since we are having the change in the LSB bit. Similarly, on comparing 0 with 8, we can observe that there is a change in the MSB bit, and so we will be writing dash in place of MSB and keeping the remaining bits as it is, that is dash and 000. Now we will be comparing between index 1 and index 2, and on comparison with 1 and 9 we can observe that the change in MSB bit, that is dash and keeping the remaining bits as it is, that is 001. Similarly, on comparing with 8 and 9, we can observe that 1000 and 1001, that is the change in the LSB bit. So we will be writing over here 100 and dash. Similarly, we will be comparing index 2 with index 3 and index 3 with index 4 and obtain this entire table number 2. This is the table number 2 that we have obtained on successive comparison of the groups of column 1. Now we will be repeating the same procedure to obtain column number 3, that is comparing the two successive groups 0, 1 and 8, 9. We will be getting the change in the MSB and keeping the remaining terms as it is, that is dash 00 dash, and obtain in column number 3. The next comparison would be between 08 and 19, and it would result in the same answer, that is dash 00 dash. So we won't be repeating the same column. Now on comparison between the next two groups, you will be getting over here 6, 7 with 14, 15 to obtain dash 11 dash, since there is the change in the MSB bit. Similarly, 6, 14 and 7, 15 would result into this already existed minterm. Here, on obtaining column number 3, we can see that the minterms like 9, 13, 13, 15 and the terms in column number 3 are not further paired, that is, they have the change in more than one bit in their binary representation. Let's give them the name as P, Q, R and S. Since the further pairing of these four terms is not possible, they are called as prime implicants. Now, the next step would be to prepare the prime implicants table. The minterms corresponding to P are 9 and 13. Similarly, those corresponding to Q are 13 and 15. Let's put tick in front of those minterms. For example, P with 9 and 13, Q with 13 and 15, and so on. Now, on observing the entire table, we can say that 0 can only be covered with R. Minterm 1 can only be covered with R, and the same minterm 8 can only be covered with the inclusion of R. That's why R is called as our essential prime implicant. On covering R, we can also cover the minterm number 9. Now, on further observation, we can include S in our list of essential prime implicants covering minterm 6, 7, 14 and also 15. That means it is essential to include these two minterms, that is R and S expression, in our final Boolean expression in order to cover the given set of minterms. Here, after the definition of R and S as essential prime implicants, we are left with only one minterm, that is minterm 13, which can be covered with P as well as Q. So we would be taking either P or Q in our final Boolean expression, and the final Boolean expression would be equal to R plus S, which are our essential prime implicant, and plus P or plus Q, that is R plus S plus P or R plus S plus Q. We can include either of P or Q in our final Boolean expression. Now let's have the final Boolean expression in terms of A, B, C and D, which are the variables. R corresponds to, let's say, in our previous column number 3, our R corresponds to dash double zero dash, and we will be mapping the same thing over here, that is R is equal to dash double zero dash, that is B bar C bar. Similarly, S is dash double one dash, that is B and C. Q is 1 dash 1, that is ABD. P is A C bar D. And the final Boolean equation, which would be our reduced Boolean equation, would be equal to R plus S plus P, that is B bar C bar plus BC plus ABD, or R plus S plus Q, that is B bar C bar plus BC plus A C bar D. Now I request you all to please pause the video over here and solve the given set of minterms. The answer for this is given in terms of column 1 and column 2. Column 2 is obtained after the pairing of the successive groups of column 1. From column 2, we can obtain the essential prime implicants reduced table, and the final reduced Boolean equation is as shown over here. Thank you.